All right, buckle up, everybody, because today we're diving into something pretty wild. What if, just hear me out on this one, what if reality itself, everything we see and touch and experience, is actually information? Not some kind of mystical energy field, no, but pure, unadulterated information.
It's definitely a mind-bending concept, right? But that's what we're here for, to explore the cutting edge of science and see where it leads us. You've given me some seriously fascinating research papers and notes on this new information-based framework, and it's safe to say this stuff is pushing the boundaries of physics in ways we haven't seen in a long time.
So let's try to break this down for our listeners, because we're not just talking about bits and bytes on a hard drive here, right? This is saying that information at its most fundamental level might be the very foundation of everything. Mass, energy, gravity, even the speed of light, which, we used to think of as this absolute constant.
Exactly. That's the core idea here. It's suggesting that everything we perceive as physical is actually an emergent property of information, a kind of complex tapestry woven from threads of pure information.
Okay, so help me visualize this. You're saying the universe is like, what, a giant computer simulation, but instead of pixels, it's all about information. How much is packed in, how it's organized, how it moves around.
That's actually a pretty good analogy. This framework proposes that everything we perceive as physical mass, energy, gravity, even the speed of light, is actually an emergent property of information.
Okay, well, hold on a second. So you're saying this coffee mug in my hand, this is just like information?
In a way, yes. Think of it like this. The atoms and molecules that make up your mug are arranged in a very specific, highly coherent way. That structure, that precise pattern, that's information. And the denser and more coherently that information is packed, the more mass it has.
All right, I think I'm starting to get it, but there's a lot to unpack here. So much we take for granted about the physical world. But what about energy and gravity? Where do they fit into this information picture?
Great questions. And this is where things get really interesting. So this framework basically says that energy is the rate of information change, how fast information density shifts and transforms within a system. Think of it as the processing speed of the universe. The faster the information changes, the more energetic the system is.
Okay, so like a blazing fire has a higher rate of information change than a rock just sitting there.
Precisely. The chemical reactions in the fire are rapidly changing the information structure, releasing energy in the process, whereas the rock has a much more stable information structure.
Got it. So more change equals more energy. But what about the speed of light? How does this ultimate speed limit fit into a universe built on information?
Well, this framework suggests that the speed of light isn't so much about light itself as it is about the maximum rate at which information can travel through space-time.
So even in a universe built on information, there are still limits.
Absolutely. There's always got to be some kind of fundamental limit. And in this case, it's the speed of information, the cosmic speed limit.
Makes sense. So it's not that things can't go faster than light. It's that information itself can't travel faster than that. This is really blowing my mind. It's like everything we thought we knew about physics is being turned on its head.
It's a paradigm shift for sure, a whole new way of looking at reality.
And this is just the beginning, right?
Yeah.
We've only just started scratching the surface of this information-based universe.
Oh yeah, we've got a lot more to explore. We've laid the groundwork, the basic concepts, but now we can really start diving into the implications, the mind-blowing possibilities.
I'm ready. Let's do it.
One of the most intriguing things about this whole information framework is how it tackles some of the biggest paradoxes in physics, especially when it comes to black holes.
Yeah, black holes, those cosmic enigmas, they warp space and time, seemingly defying the laws of physics as we know them. So how does thinking about the universe in terms of information change how we understand these gravitational behemoths?
Well, the thing is, according to Einstein's theory of general relativity, a black hole's singularity, that point at its center where gravity becomes infinite, should have infinite density. But, you see, infinite density creates a mathematical paradox. It's a point where our understanding of physics just breaks down.
Yeah, it's like trying to divide by zero. The equations just stop working. So how does this new information-based framework get around that?
Well, instead of seeing black holes as these objects with infinite mass, it suggests that they're actually regions of extremely high information density and coherence. It's like, imagine them as cosmic hard drives, packing an insane amount of information into an incredibly small space.
So the singularity isn't the point of infinite mass, but more like a point of ultimate information compression.
Exactly. And since information, even at extreme densities, doesn't create the same mathematical problems as infinite mass, this framework provides a more elegant, more consistent way to explain what black holes really are.
That actually makes a lot of sense. But hold on, if gravity is a result of these gradients in information density, as this framework suggests, then wouldn't that mean black holes with their incredibly high information density should have an even stronger gravitational pull than what general relativity predicts?
That's a great point. This framework doesn't necessarily contradict general relativity's predictions about the strength of a black hole's gravity. What it does is offer a different explanation for the underlying mechanism. You see, general relativity explains gravity as the curvature of space-time caused by mass and energy.
Right, like that classic analogy of a bowling ball on a trampoline warping the fabric of space-time.
Exactly. But in this information-based model, the curvature of spacetime is seen as an emergent property of how these information density gradients affect the flow of information itself. So a black hole's intense gravity isn't just about its mass, but about how its concentrated information structure distorts the surrounding information landscape.
So it's not like a bowling ball on a trampoline, but more like a super dense information cluster shaping the flow of information itself.
A much more accurate way to think about it, and this leads to some really exciting possibilities. If we think about gravity as ultimately being about these gradients in information density, then theoretically we can manipulate those gradients to do some pretty incredible things. Things like creating artificial gravity, reducing an object's weight, or even, and this is where it gets really wild, achieving anti-gravity.
Anti-gravity. Now that's a concept that would turn our world upside down, literally.
Hmm.
But okay, let's take things one step at a time. We've talked about gravity, black holes, and how this information framework changes our understanding of them. But what about time? Does this new way of thinking affect how we understand time as well?
Absolutely. This is where we start getting into the realm of Einstein's theory of special relativity.
Time dilation, length contraction, all those mind-bending things that happen as we approach the speed of light. So how does this information framework explain those phenomena?
Well, special relativity tells us that time and space are relative, not absolute, and that their measurement depends on the observer's frame of reference. But this information-based approach suggests that these relativistic effects aren't just about motion through space, but also about limitations in information processing.
Limitations in information processing. So are you saying that time slows down not just because you're moving fast, but because there's too much information to process at those speeds?
You got it. Think of it like this. As an object approaches the speed of light, its information density increases relative to a stationary observer. This higher information density requires more processing power, which effectively slows down time from the perspective of that observer.
So time dilation isn't just about motion, but also about how much information needs to be processed within a given system.
Precisely. And this new interpretation of time dilation has some pretty interesting consequences for something called the Lorentz transformations, which are these mathematical equations that describe how time and space measurements change at relativistic speeds.
Wow. Okay, so we're talking about rewriting some of the fundamental equations that govern our understanding of special relativity.
We are.
This is getting pretty intense.
It is, but it's worth it, trust me. So traditionally, the Lorentz factor, which is the part of the equation that determines the degree of time dilation and length contraction, is based on the object's velocity relative to the speed of light.
Right, the faster you go, the greater the time dilation and length contraction.
Exactly, but this new framework is saying that the Lorentz factor isn't fundamentally about velocity, but about the difference in information density between the moving object and the observer.
So instead of velocity being the key factor, it's the difference in information density that determines the degree of time dilation and length contraction.
Precisely. And this leads to a truly mind-blowing possibility. If we could manipulate local information density, we might be able to engineer different time dilation effects without needing to reach those incredibly high speeds. We could potentially slow down or speed up time within a specific region of space.
Okay, hold on. Now you're talking about time travel. Manipulating information to control time itself. That sounds like something straight out of a sci-fi movie.
It might sound like science fiction, but it's a direct consequence of how this framework views time as a function of information processing. And if we can control information, who knows what's possible?
All right, give me a minute to wrap my head around all of this. We've gone from black holes being like giant cosmic hard drives to time dilation being a result of how much information a system has to process. It's like Our whole understanding of the universe is being flipped on its head.
It's a huge shift in thinking, that's for sure. And like any major scientific revolution, it brings up way more questions than it answers. But those questions, that's what keeps us moving forward, pushing the boundaries of what we know.
Okay, so let's tackle some of those questions then. We've talked about how this information-based framework changes how we look at existing physics. But can it actually explain things that our current models can't? Does it have any real predictive power?
That's the big question, isn't it? And it's still pretty early, but there are some hints that this framework could help us solve some of the biggest mysteries in cosmology.
Really? Like what? Give me an example.
Well, take the accelerated expansion of the universe, for instance. Right now, we explain that using dark energy, this mysterious force that we don't really understand, it's kind of like a placeholder, something to make the equations work, but it doesn't really tell us what's going on.
Right. Dark energy, it supposedly makes up something like 70% of the universe's energy, but we have no clue what it is. So how does this information-based framework change that?
Instead of needing this mysterious dark energy, this model suggests that the accelerated expansion is actually just a result of the universe's constantly increasing information content. As the universe expands, it creates more space, and according to this framework, that means more room to store and process information.
So the universe isn't expanding faster because of some unknown force, but because it's constantly generating more information.
Exactly. It's like the universe is this massive computer that keeps getting bigger and more powerful, and that growth of information is what's driving the expansion of space-time itself.
Wow, that's a completely different way of looking at it. But if information is what's driving the expansion of the universe, what does that mean for the end of the universe?
That's a great question. And it definitely throws a wrench into our current predictions, which are mostly based on dark energy.
So what does this information-based model say? Does everything just dissolve into pure information?
It's hard to say for sure, but some people who support this framework think that the universe might eventually reach a point of information saturation. Like, imagine a computer's hard drive filling up. Eventually, there's just no more room for new data.
So if the universe hits its information limit, could that stop the expansion or even make it collapse in on itself?
It's definitely possible. Or maybe it leads to some kind of phase transition, a fundamental change in the nature of reality as we know it. The truth is, we're only just beginning to explore the implications of this framework. Those big existential questions are still out there, waiting to be answered.
Okay, well, let's step back from the end of the universe scenarios for a second. What about some more practical applications of this information-based understanding of the universe?
Oh, the possibilities are huge and honestly pretty mind-blowing. We've already talked about artificial gravity and manipulating time dilation, but there's so much more.
All right, let's start with energy then. If energy is just the rate of information change, like this framework suggests, could we tap into that somehow? Could we use information itself as an energy source?
That's one of the most exciting areas of research right now. You see, according to this framework, even the vacuum of space isn't truly empty. It's actually filled with highly coherent information, structured in ways we're only beginning to understand.
So you're talking about vacuum energy, that theoretical source of unlimited power that physicists have been trying to harness for decades.
Exactly. But the challenge is figuring out how to extract that energy without messing up the coherence of the vacuum itself. It's like trying to take water from a perfectly still lake without causing any ripples.
Yeah, sounds pretty tricky. But if we could do it, we're talking about essentially unlimited clean energy, right?
Limitless, clean, and available anywhere in the universe. It would completely revolutionize space travel, energy production, everything. And that's just one application. Think about computing. If information is the fundamental building block of reality, could we create entirely new ways of computing based on manipulating information at its most basic level?
So like quantum computing on a whole other level.
Yeah.
Artificial intelligence. That's way beyond anything we can imagine right now.
It's definitely within the realm of possibility. And then there's communication. If we can understand and control how information flows at the quantum level, could we communicate instantly across vast distances, maybe even across time itself?
Okay, now that's getting a little too sci-fi for me. But that's what's so cool about all of this, right? The possibilities are endless, even if we're still a long way from realizing them.
I agree. It's incredibly exciting. This information-based framework is like a map to a whole new world of possibilities, and we're just starting to explore it.
Well, I think we've given our listeners a lot to think about today. We've gone deep into this information-based universe, from the basic concepts to its potential to revolutionize how we understand everything from black holes to time travel.
It's been a fascinating journey, and I think this is just the start of a much bigger conversation.
Absolutely. So to all our listeners out there, we'll leave you with this final thought. If information really is the fundamental fabric of reality, what does that mean for us? Are we just complex patterns of information, or is there something more to our existence?
Maybe the answer lies somewhere beyond physics, at the intersection of science, philosophy, and our own personal experiences. The search for understanding never ends, and as we keep digging deeper into the nature of information, we might find that the universe is even more amazing and mysterious than we ever imagined.
And on that note, until next time, keep exploring, keep asking questions, and keep those deep dives coming.